Good afternoon, everybody. My name is Charlie Nicklin. I'm Chief Executive of IAgrE, and I'd like to thank you all for joining our final presentation of 2025. I'd like to welcome Dr. Jonathan Wolfson, who is a lecturer in Systems and Mechanical Engineering from Loughborough University. Jonathan is the project lead for Aftrak, which deploys economical solar microgrids into African communities, giving them access to green energy. And this energy can then be used to tailored equipment such as small tractors to empower smallholders to increase crop yields and, of course, generate an income. As usual with our lectures, everybody will be muted, and if you'd like to ask questions, please pop them in the chat at the bottom of the screen, and then at the end of the presentation we can unmute you so you can ask in person. Okay, I'll now hand over to Jonathan.
Fantastic. Thank you very much, and lovely to meet everyone. Let me see if I can find the share button. Right, so thank you very much for the introduction. I'm Dr. Jonathan Wolfson, and I sit here with probably two main hats at the moment. So the first is my lectureship at Loughborough University. I'm a mechanical engineer. I've come through an automotive route. I've done lots of things in emission systems and different vehicle drivetrains and dynamics, but have been moving heavily towards green energy and specifically green energy with agriculture. And that's where my next hat comes in, which is a founder of Aftrak Limited. So Aftrak is a spin-out company from Loughborough University. It's based off the back of some research we started about 2.5 years ago, where we were traveling through Malawi, or I was traveling through Malawi with the British government looking at energy access issues. We were visiting the different production sites, we were visiting the different grid infrastructure, but also the end users and the connection points. And the remit of why I was in Malawi was to look for energy solutions. How do we get green energy to people? But what became really, really apparent to me very, very, very quickly was that the challenge is not just green energy. You can't just go there and go, right, great, here you go. Now you have electricity. Lucky you, off you go. It doesn't work because the whole economic cycle doesn't catch up. So the underpinning aspect to the entire economic prosperity of the country is agriculture. And agriculture is very, very limited in Malawi to purely hand tools. So we started looking at solutions for that. So if I go through a little bit, hopefully, of a background to the scope. So the background, I'll do this in two parts. I'll do the energy one first, because that's where we started, then transition heavily down the agricultural route, and then I'll go down the agricultural background. In Malawi, we have a country which has about 20 million in population. So it's smaller than the UK. It's much more spread out than the UK. Population centres are spread around the main arterial roads, and then we get out into savannah any further away from the roads. But what that means is that electricity distribution across the country is a really big challenge. It results in only about 11% of the population being actually connected to the electricity network and grid. That grid becomes quite unstable because it's heavily reliant on hydroelectricity, it's heavily reliant on solar, and then it has some diesel backup generators. But what that means is that your generation in the day, brilliant, lots of electricity. You have this base load of hydroelectricity that you have no control over. But when people switch the lights on at night, the grid doesn't have that response to be able to cope with it. And so we get planned outages, we get rolling blackouts. And so really adding more people to this network is a major challenge because not only is the electricity generation not there, the network isn't in the correct places for those people to connect to. And even just the lower level connection architecture. I know many communities that are living in Malawi that have no electricity, have never had electricity, but live underneath a power line, which is madness. But it costs so much money to connect to that high voltage power line that it's not viable for the community. If you look at the whole population, we get to a point where only 76% of them have, 24% of them have any electricity whatsoever. And what I mean by that is access to solar lanterns, little home battery systems, even just a solar light. Now that's an insanely low figure. That means that 75% plus of the population are sat in darkness at night. At about 6 o'clock in the evening, the sun goes down. It's equatorial, so the sun goes down really quickly. And then you have pitch black for the next 12 hours before the sun comes back up. That's very, very limiting, both socially and economically, because you're in a situation where there is really very limited tasks you can do after that 6 o'clock. And I think, I'm not sure anyone in the room here goes to bed at 6 o'clock and goes, right, I'm done for the next 12 hours, and gets up the next day and carries on at 6 o'clock in the morning. So without that lost parcel of hours, that 4, 5, 6 hours, depending on how much you sleep in the evening that you've lost, your productivity goes down, your livelihood goes down, your ability to access additional education decreases. So it's a major issue. So these are the two primary challenges we're trying to fix with energy. It's how to make enough energy and at the right time for the users to use it, and how to connect all of these people in this disparate country to the electricity network or to an electricity source. The agricultural challenge runs along the same sort of line. By the World Bank definition, 71% of the population live in poverty. What that means is they are not growing enough food to subsist. So the poverty definition changes from, let's say, the UK poverty definition to the Malawian poverty definition. The Malawian one is very much based around subsistence. So if you're not growing enough food really to produce enough starch in order to keep yourself alive for a year, that's where you hit the poverty line in Malawi. And 71% of people live below that line, which is a horrible state of affairs. And that feeds directly from not just the available farmland, but the amount of farmland you can work and the production of that farmland. So most people are smallholders. Smallholders are women-led usually. It's a matriarchal system, so they pass down the women's line from women to women because the men go out and try and earn extra money with additional jobs. But that acre of land that person might be contributing to only will yield, or sorry, that hectare of land will only yield about 2 tons of maize. Now, 2 tons of maize isn't really enough for a 4-person family, but it's also about the limit of what you can reasonably hope to farm with hand tools, just a mattock, within a year, with a lot of manual labour. But the problem for that is much more widespread than just the availability of tooling and the availability of land. It's almost a systemic problem with how farming has been conducted in the region for the last 100 years. Malawi is now at a point, just like many, many other African countries, where it's developed a layer of hard pan, a compacted soil layer that goes down 0.5 metre in places, but usually about 300 to 400 millimetres. This hard pan layer, because it's quite a high clay content, and the clay content isn't particularly saturated with water, it binds into a brick-like substance, and water is unable to penetrate through that soil. So it means you get a lot of runoff. It means you get a lot of surface water runoff, but it means the plants can't anchor themselves, and it means you get very severe wet-dry swings, so drought swings. So as the rains stop, you get a huge amount of water, and that's damaging the soil, eroding the soil, damaging your planting. And when you move to a dry spell, which can come the next day, that soil will dry out almost instantly because it's absorbed no water because of the compaction. And then your plants are starving for water. It carries on to being a way more major problem than just the farmland, which is an enormous problem on its own. It actually affects your groundwater and your aquifers. By having this layer of compacted earth, the aquifers that the people are using for drinking water and in some places for irrigation are actually severely drying up. And it's because the water isn't penetrating into soil and replenishing the aquifer continuously. So this is a major challenge that we set out to try and tackle. As an academic, we can sit here, we can have the best ideas in the world, but until you have partners on the ground, until you have active engineers, until you're actually producing the hardware, talking to the people, getting it in the hands of farmers in Malawi, you're never going to make an impact. So what we did was we put a little consortium together. We went around and found the experts we needed in order to try and trial mechanized agriculture in Malawi, along with green energy. This initial partnership was between Loughborough University, which is myself, and the rest of my team here at Loughborough, and Taeni. Taeni are an agricultural charity in Malawi and in the UK. They specialise in deep bed farming. So this is an agricultural methodology that's very well documented now. It's fully available. I'll go through it in a minute, but it's fully available online as well if you wish to look it up. It's essentially a process of breaking that hard pan and then proceeding with a renewable agriculture process so that you can increase your crop yield. And they can show really significant crop yield increases. So we're using their expertise alongside the Consortium for Battery Innovation, which has those big player industry links. So the big battery manufacturers, the big motor manufacturers, the big vehicle manufacturers, all of those links we can access through the Consortium for Battery Innovation. So this was our first initial consortium that we put together, and we went out and we started to apply to innovate, to look for some funding to do feasibility studies within Malawi, looking at solutions to mechanized agriculture. So the concept we put forward at this point was to use a fully economic system, a system where we deploy a solar microgrid. So this is a grid connected to homes producing electricity. These solar microgrids typically have major problems within countries like Africa and Malawi because they tend to fall into disuse. And they tend to fall into disuse because when they're deployed, they're often funded. And people show up, install a big solar array, big battery array, connect all the homes to electricity and go, there you go, and off they wander. The problem is that that solar array then is connected to a community that's never had electricity before. And so they don't own lights, they don't own kettles, they don't own fridges or televisions. So the base load on that solar microgrid is very, very low. It means that you're not selling a lot of electricity to the community isn't buying it, and so there isn't income going back into that solar microgrid. And there are dozens of projects now across Africa that have failed in a very short amount of time, sort of 2 to 5 years, because there isn't a continual revenue going back into that microgrid in order to support its maintenance, its upkeep, and its ongoing use. So that's where the next part of our system comes in. So we deploy the solar microgrid. It's relatively standard, although we've done some very special design with it that I'll talk about in a bit. The next part is to deploy microelectric tractors beside it. So these tractors are deployed at the same time as the solar array. What they provide is an immediate use case for that electricity. So from day one, that solar array is exporting electricity, it's selling electricity, it's providing an income, it's making itself sustainable by providing that income, selling the tractor services. The tractor's fully electric. It's a battery-powered system that charges overnight or during the day from the solar array. And the idea of that tractor is we enable deep bed farming. So it can do that deep tillage down to 300 to 400 millimeters, which breaks the hard pan. We then follow the deep bed farming field manual. We can show a significant increase in yield, and we're talking 2 to 3-fold increase in yield. So it's very significant. That increase in yield pushes people past the subsistence line. And once you're past the subsistence line, you can start selling your excess crops to market. That excess crops generates income. That income is for the farmers. Some of that income gets spent on electricity from the solar microgrid, and suddenly this economic loop is complete with the money flowing all the way around the system, provided predominantly by agricultural prosperity. So deep bed farming is one of the secret sauce elements to the whole thing, because you need to have that methodology for increasing your production from your land. So DBF is a climate smart method. It's designed predominantly to break that compacted soil, allowing water, air, roots to penetrate properly. What it shows is that the land becomes 9 times more profitable in the first year and up to 12 times after year 5. The reason that's so high is because you're going from a very, very low profitability margin. If you're very close to that subsistence line, you're self-consuming most of what you grow. So if you can push people over it, the amount of income they get goes up very significantly versus the amount of crop yield increase. It's been shown very conclusively, actually, that it reduces soil erosion very significantly. It refills groundwater aquifers in regions where we've started doing deep bed farming. We're seeing wells that have been dry for decades coming back to life. We're seeing boreholes produce more water much more consistently. And it's because the soil's now much, much healthier because it's active again, it's alive again. There's air penetrating to the soil, there's microbes penetrating to the soil, the general health has gone up. So we're basically restoring that climate. I know we frequently talk about tilling as bad. We do no-till. We don't want to disturb the land because we release carbon. This is a very different scenario and environment because the land that we're talking about tilling is completely dead. It does not have stored carbon. It does not have stored microbes. It's compacted to the point where it is completely inert to life at that point. So by tilling it once, we till it down to the appropriate depth to provide this penetration and root depth, it means that we're basically revitalizing that land, and that land becomes a carbon sink in itself. So we don't till it again in year 2 or year 3 or year. This is just an initial process to break the soil and get it going again. So in a bit more detail, we have a full, or Tiny has published a full deep bed farming field manual. This field manual explains step by step the entire agricultural cycle how you break the hard pan, how you set the beds up, and how you do the planting and sustainable composting to make sure that we're keeping the nutrients within the land. In short, in the first year, we're doing this big job, which is breaking the hard pan, so the soil decompaction. So we're doing tillage down to at least 300 millimeters. Then we're setting out contour ridges. So because the rains are so severe in Malawi, and actually looking out the window probably here as well, Malawian agriculture needs to run perpendicular to contour lines. Did I say perpendicular? Parallel to contour lines. Let's try that again. Parallel to contour lines. And that means that the water isn't running directly down the ridges within the field, it's running against them. So it's collected and it's stored. Then we set up the construction of the deep beds. So we construct furrows. These furrows are there to catch the water when it comes down in huge quantities and give it time to absorb back into the soil. We set up the beds. The beds are usually planted with maize, depending if they're after just the staple starch, because maize is a really, really resilient crop. But then it is intercropped with binding root crops to bind the soil, keep it supportive, but also to put some nitrogen back into that soil. So when we then run this, we run this with cultivation based on just manual manure placement. So we collect all of our green waste, we compost all the green waste, we use that as the nitrogen and the fertilizer source. And we do that over and over and over again. And when we look at the comparison, what usually happens in these practices like slash and burn are remarkably common in places like Malawi. And that's because of purely labor limitations. So if you go through and you cut your crop down, it's much quicker to burn that crop to get it ready for next year's planting cycle than it is to go and clear the stalks, cut the stalks, and then collect them and either compost them or we lay them as well to keep water into the soil to stop evaporation. So then you get back into your standard sort of agricultural cycle. So we go through a standard harvest, we go through a standard maintenance bed prep season, where all we're doing is basically refreshing that bed. We're laying the stalks when they've been cut. We're keeping it moist, and then we refresh the bed for next year's planting. So there's no extra tillage gone after it, and there is no additional walking. We're very strict in terms of the training, in terms of where you can walk on or off the soil, so we don't reapply that compaction that we built up over the decades in Malawi. If anyone's interested in more specifics on deep bed farming, I am an energy engineer. A lot of my team are pure agricultural engineers, but this isn't my specialty. I've obviously learned loads about it in the last 3 or 4 years, and it's a brilliant technique, but the full field manual is available online. So if you look for deep bed farming with Tiny, you'll be able to download the complete set of instructions for an annual field manual, as well as all the supporting journal papers and literature, looking at the benefits and improvements from running the practice. The big headline numbers are that at the moment in Malawi, we've already onboarded 37,000 farmers. Now, that's a huge number. We've got a large amount of data proving the efficacy of growing crops in this manner. This is predominantly spearheaded by Taini, who run a network of field managers across the country. So they assign different communities each year. That field manager will work with that community to train individuals on how to do deep bed farming, and then they will monitor their process and keep up to date with them for the next 3 years to make sure the cycle continues. They're doing fantastic work in there, and what they're finding is that we're now shifting heavily to a train the trainers model. There are so many people in Malawi that are actively practicing deep bed farming that people are training their neighbours without the need for Tiny to step in and offer field monitors and field support. This is helped by the fact that deep bed farming is now the Malawian government's approved and only approved agricultural methodology, that they're saying, yes, you can go and roll this out across the country. We have a very high percentage of women uptake. That's partly because of the matriarchal system in Malawi. So the fields are owned by the women, they're typically farmed by the women. But the critical number is the next one, which the average yield increase for a deep bed farming field goes from 4.2 tonnes for a really well-farmed, traditional farmed field to 7.8 tonnes a hectare for deep bed farming. So it is a really big increase, and that pushes your profitability way beyond that, way beyond 10 times. The drawback is, of course, with anything, is the upfront labour and the upfront work. So deep bed farming requires you to dig through this compacted hard pan layer. Now, I'll be absolutely honest here. The video you're seeing, this is Nicholas. Nicholas has been practicing deep bed farming for about 3 years now. And so the field he is currently working is more for show. So this field isn't actually compacted earth. This is a previously grown field, hence why you can see the life in it. It doesn't look like scrubland. But the practice that he's doing with the mattock here is exactly the way we work through the deep bed farming fields. We basically dig a trench 300 mil down, and then you work away at the edge of that trench, moving forwards to get through the 300 mil depth that you need across an entire field. Now you can imagine the effort that takes, and certainly myself and my colleagues, we wanted to experience this. We sat down here in Loughborough and we tried to turn a field over with a mattock. We gave up pretty quickly. It's horrible work. And so this is what's putting people off deep bed farming. This is why that you can't go out and tell the entire country, look, if you do this, you'll grow more food, and everyone gets on board, because there's this large amount of upfront labour, and your return is essentially 9 months later. So there isn't that direct reward for the effort that you're putting in until you start growing more food. So this is where Aftrak comes in. Now, what you see here is version 1 of the Aftrak tractor, and as a spoiler for later on down the slide, doesn't look anything like this anymore because we've done lots of development since we started doing this. But this tractor here was our very first feasibility prototype that we deployed in Malawi. On board was about 10 kilowatt hours or 210 amp hours of lead battery at 48 volts. So that is a whopping battery. It weighed best part of 400 kilograms in total, purely lead. That powered a DC brushed motor, a 5 kilowatt brushed motor that was powering a earth saw on the front. So this chain trencher that you can see was the method we were using at this point to get down to that significant depth. The problem we're facing, of course, is just the power versus depth that we need to get down to, because we haven't got access to several ton tractors to drag a decent sized plough through the ground. We haven't got the weights or the traction to drag a subsoiler through the ground. So we're very much limited to what we can do with powered tooling that leaves very low force on the tractor unit. And so this is why this chain trencher comes in as quite effective, because it uses a high-speed chain that's essentially obliterating the soil before it allows a lot of force to build up on the tracting unit, which was effective. It has a huge amount of drawbacks, which I'll go through soon. Then I'll go through what exactly we're doing now. But this tractor unit itself had all the other bells and whistles built into it. It had its own solar panel on top. It had a little AC inverter so that you can take the tractor home. You can use it for powering irrigation pumps. You can use it for powering lighting, all as a standalone system. And this unit was coming to around £6,500, which is affordable, is also way higher than we want to be for a unit such as this one. The tooling, as you can see, is this carbide tipped trenching tool. So this comes straight off a standard trencher. It can go down to at least 400 millimeters in depth. It tends to work with very, very low force in very dry, hard soil. So it's designed to chip away at rock solid soil consistently. It takes quite a large motor. So this is the 5 kilowatt motor directly on the back of it. And it was basically the technique that we came across that was going to be suitable for getting the depth we needed for deep bed farming. You can see as well the inverter that we installed in this at the side. This was at a demonstration site in Stellenbosch in South Africa. Obviously, Stellenbosch is hugely affected by load shedding. So South Africa has a large amount of under-generation problems. And so you have several hours of the day where there's no lights, no electricity. And it was very nice for us to show up the tractor that we were demonstrating and plug basically half a university there into a tractor and power it off that one. So that was quite a win for us. So let's go through some of the learning as we did this, and then through some of the design revisions. Again, this is fairly high level. There's lots of data that goes behind this, so I'd welcome any questions you've got when we get to the end. So the earth saw was very, very effective at cutting through the ground. It didn't use a lot of traction force. It did cut through hard soil very easily, even cut through a lot of wet soils very easily. What we found as well was that it was basically unfazed by anything less than a boulder. It went straight through roots, and it cleared straight stones very easily and very simply as well. So we didn't have any particular issues with the actual practice of using it. The issues came in when we looked at the environment and the overall use for the user. So one thing that we found that was fascinating actually was the soil in Malawi is quite high clay content, but it's also quite dry. When we put it through the chain, it made its way into the bushings on the chain, which normally would have been fine. And in our testings, it was fine. But with the exact moisture content that the soil had about 2 months after the rainy season, the pressure within that bushing is enough to bind the clay into a solid particle. And what you found was that the bushings got tighter and tighter, and eventually the chain shortened overall. And that shortening of the chain eventually worked its way up to a binding. All you had to do to clear the binding was basically beat on it for a little while with a hammer to clear out those bushings. But obviously that's a major issue that we don't want in our final product. What we also found was it's quite hard to source components for the chain. The chain itself is relatively specialized. It's cheap to buy, but it's only purchasable in very few locations. The teeth themselves, the teeth that were being used in this one are carbide tip teeth. They're completely not suitable for Malawi because they're impossible to source. You'd have to ship them out there and they're quite expensive. The plan was eventually to change those over to welded steel. So you just weld new teeth on over and over and over again. Welding is one practice that's heavily available in most of Africa. So you can easily do repairs that way. But the risk realistically for that chain was a bit too high for us. So the expense and the risk for maintenance just didn't add up to be a reliable, useful, long-term product. We also found that the coverage that we were getting, because the chain is quite narrow in order for it to work with such a small device, we found the coverage for the land wasn't sufficient really to cover your sort of hectare that we're aiming for in a day. And so that decreases adoption, which is a problem. Likewise, on the controllability, obviously we gave this to many, many different people. We had them drive it around. This tractor here runs with a bimotor setup. So each wheel is driven from its independent motor, and you have two thumb switches. So if you go for this thumb switch, the tractor turns right. Go for this one, it turns left. Which, if you've driven scooters, if you've played PlayStation, any of the kids nowadays, very, very suitable for them, very, very useful. When you take it out to Malawi and you give it to a community out there, it became very difficult, a really big learning curve to figure out how to drive this. Coupled with the expectation that you were walking backwards with the chain trencher, it basically made this not as acceptable to the community as we would have liked it to be. We also found, interestingly, that the dust produced by the chain trencher, because it's quite a fine particle that's being produced out the back, that dust was seen very socially negatively by the community, because the community is completely unused to mechanized agriculture. They've never even seen a tractor in a field. So the fact that a tractor produces dust is something that raised huge red flags for this community. And this is something we've been trying to address with a change in tooling later on, so we can pick up that acceptance and that acceptability to the community. So I promised that we've had a big revision. Here's the next version. So this version looks vastly different. It's actually got more battery capacity and more motor power, and is a much more capable machine overall, but it's got a lot smaller in the process. So the weight for this one's gone down to about 150 kilos now, so significantly lower than our half-ton for the previous tractor. We've changed battery technology. The battery's moved from a lead-acid battery, which was very convenient for the first tractor because we had some fantastic partners who were helping supply batteries. And so we had a big supply of free lead-acid AGM batteries. But as we moved on, they became a real limiting factor because the weight of the whole module meant that you couldn't easily pick up and move the tractor around. You couldn't put it on the back of a trailer. You couldn't put it on the back of a vehicle. You needed proper ramps to lift it. And it made the accessibility of the tractor significantly worse. So we've moved over to a lithium battery. We've got some really good suppliers of very rugged lithium iron phosphate batteries. Designed to take the vibration, they're designed to take the heat, they're designed to take the environment. They're completely waterproof and sealed. We've then now moved on from a brushed 5 kilowatt motor to an 8 kilowatt peak PMSM motor. The biggest reason for this is direct torque transfer. So PMSM motor works a little differently from a brushed motor. A brushed motor, the more voltage you give it, the faster it will spin. With a PMSM motor, you can essentially apply full current at stationary. So you get a much bigger low load torque or low speed torque provision, which is much more beneficial for our tractor. So we've changed the motor type and we get a much higher peak power because we can draw more power out the lithium battery. We've then removed the two independent wheel motors. So now we just have a single motor that's powering the entire device. And instead we have a 3-speed transmission that has 2 working speeds. So one slightly slower than walking pace, one that's walking pace, and then one travel speed that gets to about 15 miles per hour. Those 3 go through basically a high reduction transverse differential on the bottom, locking differential, so that you can choose whether you're using it in a field or wanted to go around corners on the road. And we also have a reversible set of handles. So the handles that you see swing all the way back round, so that with the PTO that's mounted on the back can be adapted for either forward tooling or rear tooling, depending on the process that you're doing. We've also significantly moved away from the chain trencher and instead started to do a lot of work on rotary plows. Rotary plows also work fantastically well for this sort of condition. They're very, very good for the hard soil. Because of the rate that the plow blade is moving as it rotates, it decreases the contact force on the soil quite significantly. So we're still maintaining that low traction force that we need for a lightweight, small tractor. But the big difference is that we're using basically the same amount of power to run a rotary plow, but we're now plowing a width that's 300 millimeters wide by 300 to 400 millimeters deep, depending on your tips, at a brisk walking pace. So suddenly the land coverage that we can do has gone up really drastically by changing the tooling and changing the architecture. But it's not the only tooling. So we're very aware that Africa is a big, diverse place. And so there are lots and lots of different agricultural methodologies that you might want to use. So we have been investing in a supply chain for a huge array of different attachments and tooling. So we have a mechanical PTO on the back. We also have an electrical PTO, so we can connect straight to the battery. These 2 devices can connect to tillers, rotary plows. We've got harvesters. The one you see here is a harvester and a bundler. We've got time plows, we've got mobile plows, and even ride-on trailers. My colleague, Dr. Williams, absolutely loves a ride-on trailer. Keeps riding up and down campus on it, big grin on his face, enjoying himself driving the tractor around. But the trailer just hitches onto a pin on the back of the tractor. It articulates around the trailer so that you can steer, and makes a really nice drivable thing that goes about 15 miles an hour and can tow about 600 kilos. So it's a significant amount of load that you can put on that. So there's a huge array of now different applications that we've got. So we've got one product that we can now make en masse, and that mass production product can bring the cost down, and so that we can supply it to a much bigger region and area at a much, much lower cost. Now, the current working cost for this is sort of below £3,500. So we're significantly cheaper than the first one. And that's with all the batteries included. Right, next part of the system, or the final part of the system, is the Aftrak solar modules. So obviously we can't go to Africa and drop a load of electric tractors in there and say, good luck plugging those in. So we're building the solar modules as well. And at the moment, we've built 2 fully electrified microgrids in Africa to test these modules. Each module has about 1.3 kilowatts of solar panel on the top. These will generate in Africa about 7 kilowatt hours a day of electricity. So that's quite a lot for a community that's never had access. Certainly, one of these is enough to charge a tractor at least once, maybe twice in a day. The reason we're making the modular as well is about the disparate landscape and the accessibility. So we've made a single product that comes basically in its own box. It can be put together by the community. And if you need more electricity, you just add another one next to it, and then you add another one next to it. And so we've produced a scalable solution that's really, really easy to transport and deploy. It also means that you can continuously upgrade it as your income grows and as your demand grows. This uses the same battery technology as the previous one, so it's an all-in-one module. The modules have the solar panels, they have the power output, they have the battery built in. So it's the whole shebang, all in one nice little foldable module. The frames look a bit like this. They're entirely made from aluminium, sheet aluminium. So single thickness of sheet aluminium, so we can produce them anywhere in the world. We make all these with a laser cutter, but they can be made by stamping and then become made with a plasma cutter. This means that we can put mini production sites in place in many, many different locations across the world. What it also means is that the frame itself is incredibly small and lightweight, but it gives you the ability to fold it, which gives it much greater strength. So you go from a floppy bit of aluminium, you put that bend down the middle, and it gains a lot of rigidity. So when you've built a module like this one up here, this will survive all sorts of things. I've had one which had a telegraph pole drop on it, and it stood up. I mean, the solar panel on top wasn't too happy that it got hit by a falling telegraph pole, but the frame was still stood there. And for a very lightweight bit of aluminium, it gives you lots and lots of confidence that it's going to survive the storms, it's going to survive the wind, typhoons, etc., etc. The way we've designed it to be assembled is with this sort of tongue and groove logic. So it's all like Lego, it clicks together. It's only got slots that it clicks into, but it means that you can build the whole thing with no tools. The only tool we need is a hammer or a rock if you're in a pinch. And it means that you can build it without any expertise. So we produce a multilingual manual that looks a little something like this. That multilingual manual will take you through step by step how to build the frame. And then you put the solar panels on yourself, you connect it. All the wiring's sort of pre-done inside the box. And so an unskilled user can connect it up and get electricity at the back end without risk to life, without that additional danger, because all the connectors are sealed. They're all pokey, so you can't plug them into the wrong connector, and you cannot assemble this in the wrong way. Well, that's the goal. So these ones, we've got quite a few distributed around. We've got sort of 2 main sites in Malawi where we've done village scale introduction in microgrid deployments. We've also got an additional 4 or 5 projects coming out that's going to support these microgrids. You can see the full setup at the bottom down here. So this setup has everything in it. It has the entire framework, has the 2 solar panels, has the inverter, it has the batteries, and it goes together like a Lego kit. This is one of our microgrids. So this one is in Eswatini in Malawi. It has underground trenches that the villagers have dug, and we put wires in between the homes. This is a good call for Malawi because it's a lot lower cost than overhead lines. It's a lot safer than overhead lines, and it's much less likely to be attacked by a large number of roving goats knocking around in Malawi. So as they go through, we've dug trenches about 600 millimeters down. These have been done with hand tools, but the tractor can also dig these trenches. We lay individual lines from the microgrid back to each individual home, and we create a hub and spoke model grid. This differs from your traditional mechanism for a microgrid installation. Normally with a microgrid, you'd create rings of wire that runs around the system. But with the modular microgrid, we're not aiming to connect hundreds of homes, we're aiming to connect a dozen. So it makes much more sense to have this star-shaped network. So everything comes back to the central microgrid in the middle. It means you can do all of your protection in the center. It means you've got the proper fuses, it means you've got the proper isolators, all built into the microgrid. And then you just connect the number of homes you need to. If you have another cluster of homes, instead of running a large expensive wire all the way over, maybe upping the voltage to like 33 kilovolts to transmit it, all you do is you build a separate little hub of microgrid modules. So it gives you a much lower infrastructure cost than your traditional microgrid setup in somewhere like Africa. We have done a lot of work looking at different business models, how we roll this out, how we start to look at the accessibility of the units. The simplest one, of course, is we go out and we sell them, and we certainly will be selling them. So if anyone wants to buy a microelectric tractor, get in touch. I would happy to sell you one. But we're very aware that a large number of people, especially in sub-Saharan Africa, won't have the capital even for a very low-cost microelectric tractor. So we've been working with different organizations and different structures in order to try and look at either leased models or even fully autonomous revenue-based models. So the leased models, we provide basically tracked tractors. So they have little GPS chips in them. You pay for the time you want to use the tractor for, pick up the tractor, drive it to your field, do the work, bring it back, plug it back in, just like a line bike in London. With a solar revenue model, it's a bit more of a long-term commitment with that community. Essentially, we would raise capital in order to install the solar, in order to install the tractors. This one's always risky because you want to build that community ownership. So you might want some investment and some input from the community to help with that, because then they're going to look after it and they're going to maintain it. But then you supply the tractors, and then by year 2, when that increase in profitability comes around, you start to regenerate the capital with the solar income to the array. This model is a bit more tenuous. It needs support from big players like the World Bank or the World Women's Bank in order to properly install and distribute them. It's basically going down this microgrid architecture. But this is one thing we're looking at heavily in order to massively increase the accessibility of the units across Africa. So this puts us where we are now. Aftrak is now in a position where we ran our feasibility study with Innovate UK. That went very well. We got good data out of it. Obviously, we got a lot of data, which was like, right, we're going back to redesign those tractors to the drawing board, but that's exactly what we wanted. Then we've moved on to a point where we've been lucky enough to gain a reasonable amount, $1 million in seed funding to launch Aftrak Limited, the company. That $1 million has helped us with the final product development. We now have staff on board, we have supply chains in place, and the first production run of 100 Aftrak tractor units is now in run. This should be completed by March, when we'll have the first units for sale. So it's a big step forwards for us. We've gone all the way from that original sort of academic idea going, wouldn't it be nice if, to the point where we have a limited company that's mass producing tractors for rural Africa. So for me, that's a big win. So these tractors are going to be heading out initially to a few of our key initial markets. These are Kenya, Nigeria, South Africa, Malawi. These ones have been picked not only because they've got a big need for agricultural tools and methodologies, but also because we've got good links in those countries. So it's really important to have your deployment partner, to make sure you have your maintenance partner, to make sure you're not just sending equipment out with no one to look after it and no one to repair it. At the moment, we've deployed 2 sort of village scale microgrids. So we've got a school we electrified recently. That's got a 6-module hub in the middle, and it's then got about a dozen homes and all the school buildings connected to that one. We've got another one which is in Neshwatini village. Again, about 8 homes connected to that one on 4 modules. We've got a further 4 ones that are fully paid up and planned to roll out. Kenya, Cote d'Ivoire, another one in Malawi, and another 2 in Malawi, actually. And we're starting to sort of manufacture those in batches of 20 plus, but we're planning our scale up really to try and get that to producing hundreds of thousands, so we can do this at really, really low cost. We've been talking recently to a hospital in the Salima region in Malawi. They've been looking at a quote of, I think it was about £90,000 to electrify their hospital. When we look at the comparative quote for doing it with Aftrak modules, it was sitting around the 15,000 mark. So it represents quite a significant decrease in cost for an end customer. Right, I'll stop talking. It feels like I've talked for way too long and you're probably all sick of hearing my voice. But I'd love it if anyone's got any questions or anything you want to ask about Aftrak.
Yep, got a few questions. Thank you for that. So David Clare, I think his question is probably going to be quite easy for you to answer. What's a PMSM motor?
Permanent magnet synchronous machine, or synchronous motor. It's just got the magnets in there and it's got phase, and we make the phase with the driver rather than the brushes. So it's like a brushed motor, but instead of having brushes, you put a driver that makes a wibbly wobbly phase, and the phase chases the magnet.
Okay. And then, so the next question, which is a bit more juicy, is from Mike Bennett. Mike, do you want to ask your question? Is that the easiest way?
Thank you so much, Jonathan, for that. It was really, really interesting. Is this compaction problem? I don't know whether I picked this up. Is it a general problem through East Africa?
It's a huge amount. In sub-Saharan Africa,
Yeah.
the climate really drives compaction. So you have this sort of boom bust of rainy season to dry season.
Yeah.
So
I'm coming from a long time ago, at the beginning of my career. I worked as a VSO in Kenya, and on a appropriate technology mechanization project where we were working largely with ox power, I could see that there's a problem with using oxen. You wouldn't have enough power and probably create as much compaction as you were trying to break up. But is there a history? You see, what I noticed there's a comment that Stephen Temple made about the snail project. I mean, we've been down this sort of line before. And one of the problems is it seems like you've actually managed to overcome some of the manufacturing problems of producing what is effectively high technology in a low technology situation. But is there a history of animal cultivation in Malawi? Because there is one there is one in Kenya.
Oh, absolutely. And oxen's a really interesting one. So Malawi is a country that has been the recipient of a lot of aid projects, whether well conceived or not well conceived. Some of those have been oxen projects, and certainly some of those oxen are still operating within Malawi. The part of the problem with oxen is the upkeep cost. So you've got to keep feeding them. And when you get to the point where you can't feed yourself, the first thing on the chopping block is the oxen. So it lends itself to a terminating program rather than a breeding program. So the more successful animal projects have been usually related to goats, where they can be essentially released to propagate on their own. So that they work quite effectively. With oxen, when it comes to ploughing, obviously oxen have a huge amount of force, but still not quite enough force to pull a true subsoiler. Because it's hard work, is that one. So you need a team of 2 or maybe 3 to properly subsoil down to that depth. And when we talk about hard soil, it's unbelievable the rate of it. It's literally what they make bricks out of. The process for making a home in Malawi, you basically scrape up the topsoil, you compact it and bake it, and it turns into a solid brick. And this is what's happening in the ground.
Well, one of my old colleagues is exactly trying to do that at the moment and build a new house because they've had terrible storms in Western Kenya, and he's basically needs to rebuild his house. So
it's terrible, isn't it? So,
yeah.
But it's this cycle where you've got huge amounts of water followed by absolutely none. And then you walk on the land and you mistreat the land. And without that regenerative practice, without laying crops on it to prevent the evaporation, without properly just managing that soil, it just naturally compacts over time, and it becomes a huge problem. It's spread out across Africa, and this is why you see such big yield increases. I mean, someone told me,
they're phenomenal.
Oh, it's incredible, isn't it?
I mean, we could get by actually back in the day, if you were mechanically weeding maize, you could get 50% increases in yield just from actually ox weeding maize. But even so, those sorts of yield increases that you're getting from that. But I mean, if you're coming from such a low base.
Oh, absolutely. There's so much headroom. It's very different to talking about this country, isn't it? Where we're after every last percent. You're starting from a very poor condition, and there's these big gains to make immediately in just practice. And it's not just that; it's the regenerative side of it as well. It's the composting and it's the fertilizing, because Malawi becomes a really vicious cycle. So you don't grow enough food. So what do? Someone sells you some fertilizer. So you put nitrogen on the field. And it's all nitrogen fertilizers. There's no micronutrients in it or anything along those lines. So you put nitrogen on the field, and then you get a little bit of an increase in crop yield. So the next year you buy more nitrogen, and suddenly you've spent all of your money on the nitrogen, and you're not really seeing the gains because most of it is just washing straight into the watercourse.
Tell me about it. I mean, there's the whole thing of the guy going out and instead of planting all his acreage with Kitali hybrid maize and needing tons of fertilizer to make it actually grow, trying to persuade them, look, if you've only got this pot of money, only do so many acres because you'll get a viable crop from that, and you'll be better off than if you put the whole lot in. and then don't put
Absolutely.
fertilizer to it.
And it comes back to the education
Yeah,
side of
it
things.
does, yeah.
This is heavily an education problem.
Yeah.
And this is where Tierney is a fantastic partner to have on board, because their bread and butter is agricultural education. They've literally written the book on Malawi agriculture.
Oh, it'd be interesting to have a look at that.
Do go on their website. You can download the whole field manual. There's lots of published papers on yield quantification and how it's run. So there's lots of information. So do go and have a look on the Tierney website.
Thank you, Jonathan. That was great. Thank you.
Okay, Stephen, your next question, please.
Yeah, this sort of basically follows my career. I'm now farming in North Norfolk regeneratively, but always the problem in Malawi, it was dry season cultivation, and any dust you form will sink to the bottom of the tilled layer and form a pan as soon as the rains come. So I don't know how far this system of regenerative agriculture can keep stuff growing during the dry season. It's nearly impossible in central region of Malawi, but I'm really pleased to see it, and I think I would like to support it and to support what they're doing through some of the charities I support, and but I'd like to see more details of the cultivation system. I think this is going to be the key to it in all of Malawi.
Absolutely. Again, start with a tiny field manual, because that's really informative, and then come have a chat and we'll go through the whole setup.
Thank you.
More than happy to do that. And as I say, it does look like it works exceptionally well. Again, we're on annual cycles rather than biannual cycles, so growing in the dry season is obviously incredibly difficult. So the current methodology is that right at the end of the wet season, that's when we start really the conversion to deep bed farming, because the ground is still just about soft enough to do something with, but you've got to put that effort in to break it up. However, with mechanized agriculture, that date actually pushes back a little bit, because the rotary plough and even the chain trencher can go through much drier, much harder soil without really batting an eyelid. So you really can push that date further and further back into the dry season.
Yeah, as we're being encouraged to undersow maize with cover crops in this country to retain more moisture, can you intersow the maize in Malawi with a cover crop to keep root structure in, to keep the soil going a little bit longer into the dry season?
We absolutely do always use a support crop, or at least a root support crop. Well, it was on there somewhere. I've gone back a lot of slides with a lot of videos in them. So we do always intercrop around the edge of the fields. That image isn't very good to see it, but you can see them along here.
Yeah.
So these are intercrop plants that run all the way along the edge, and what they do is they are there predominantly for nitrogen, but also to stabilize that structure, so that it doesn't get so easily washed away when it comes to the wet season.
Yeah, and presumably the Malawians will grow pumpkins underneath the maize as well.
Now they'll grow everything whenever they can. Maize is always the staple, but Tierney especially have been doing a lot of work into cash crop conversions. So that there's, with Africa, people tend to jump towards the questionable cash crops like marijuana or tobacco. But there's a lot of legs in going then for a more water hungry cash crop, so something like cotton, and using then the electricity from the microgrid as an irrigation source. So with suddenly this availability of electricity, and we've got boreholes, especially if we're doing deep bed farming, that they continue to work, then we can start adding small irrigation pumps. We're building an electric bowser to go on the back of it, which is just great fun. We're enjoying ourselves. So you've got loads and loads more options if you can bring the water back into that cycle with some form of irrigation. It's usually drip irrigation, or something similar in Malawi.
Super, thank you very much indeed. The next question is a few questions from myself. I was just a bit confused. Which version is being produced then? The one with the
this one right at the end.
way?
So I started a bit more agricultural with this one and started with where we started and ended up where we ended up. But this is the one we're making.
So has that got a solar array on it then?
So this doesn't have a solar panel on it at all. This was part of the decosting.
So the one with the curved panel that never went into production.
No, those were our feasibility tractors.
Right. Okay.
They were the ones that were a bit too heavy and a bit too unusable for.
So the one on the screen is the one that you're going to manufacture. And then the questions really were what voltage does it run at? Where's it being manufactured? And how was the whole project funded in the first place?
So 51.3 volts.
Yeah.
105 amp hours of battery capacity. Gives you about 5.3 kilowatt hours of total usable capacity. The first batch is being manufactured here in the UK because we want good supplier controllability. But I've got basically a global network of component suppliers because there's no other way to build anything nowadays. So all parts come here for the first 100 batch, and we're going to build 100 of them basically on a farm near Manchester. And then for the ones after that, we're building local production sites in individual countries. So my first one is being set up in Blantyre in the south of Malawi. I've got a partner there, which is a really reliable engineering partner called Inflow. We've got a building set aside where we're going to basically start producing kits of parts that then get assembled in country. And there's massive advantages to that. The first is import duties. If you import a vehicle, you get stung through the nose for it. If you import a battery and a chassis and bits like that, much cheaper. In fact, exempt in many cases. So we're going to assemble those kits of parts using a forwarding network around the globe, send them directly to country, train the technicians in country so that they can both repair and build, and then assemble them and test them directly in the country they're being supplied to.
Right. And in terms of how the whole project's been funded, how has it been funded? Where's the investment come from?
I'm obviously an academic. Part of my job, in fact, a vast part of my job is writing funding applications. Something we became quite good at. So the initial feasibility study was funded by Innovate UK to the tune of about £350,000. Obviously, that's government money. It's Innovate UK money. So £350,000 translates to about £38,000 to spend on equipment, which is crazy when you think about the whole process. Since then, we won a Global Innovation Prize through the Milken Institute, which is a philanthropic institute in the US. They're funded as well by the Motsepe Foundation. The Motsepes are one of the wealthiest families in South Africa. So between them, they contributed to a fund of about $1.2 million, which helped to launch Aftrak as a company.
And the intention is it to be a commercial entity that can stand on its own.
We've got to be sustainable. So we're a social enterprise, which means that we reinvest any profits back into the business rather than particularly taking them out ourselves. If we want to make this mass producible and accessible, we have to sell them with enough margin that we can make the next one and make the next one and make the next one. So we are a limited company, but we're also a social enterprise. So we reinvest everything in producing new agricultural equipment.
Yeah. Okay. All right. Thank you. There's probably just a bit of time to squeeze one more question from Juan Turion. If you want to unmute yourself, is he still on?
Yeah. Thank you. It's about. Are you thinking about applying any type of soil amendment like biochar? Like applying at this depth that you're putting there just to make sure that everything is going to stay in place. But obviously the biochar also can play another roles in productivity, etc., and to prevent this compaction. Thank you.
But biochar is a hot button topic. It's very, very interesting, especially with relation to charcoal sequestration, because charcoal is a major problem in Malawi as well as deforestation. We do have the energy to support electric cooking when we talk about these full microgrid setups. So we already have the ability to displace charcoal quite significantly with the solar, which makes an enormous carbon impact. And actually, charcoal reduction is one of the sort of the key metrics for carbon reduction in the region. But when we come to use of the agricultural byproduct, the husks and the stalks, especially the stalks, we heavily recommend those are put back into the composting cycle. They're either cut and laid so that we trap the moisture in the soil, or we take them, chop them, compost them, because nitrogen's the enemy, isn't it? If we lose the nitrogen, we've lost the soil. So because they can't particularly afford large amounts of commercial fertilizer, and that's a very non-sustainable way to be pushing people towards anyway, we want them to put every bit of biomaterial they can back into that composting process. However, I've seen some fantastic projects that I'd be very happy to work alongside that work with things like corn husk biochar as a charcoal replacement and an additional income earner, which I think add a lot of value to communities as well.
Okay, so we're just up to the hour, so I'll draw things to a close. So there are some questions left in the chat, but we can probably pick those up after. So thank you, Jonathan, for an excellent presentation. Really useful, really interesting, lots of questions there. And I'm sure everybody will have learned something today. So thanks for everybody for joining. I hope you'll join us for our next lecture on the 13th of January, where we'll be joined by Ed Seed from Hills Green, who are a specialist agricultural marketing agency who are looking about how to market technology to farmers.